Hi, science students. Today we're going to focus on deconstructing or breaking down the AKS for AKS 4B. So the AKS says, develop and use a model of how natural selection leads to changes in specific traits of populations over successive generations. That's really wordy and there's a lot to unpack there. So I want us to first just mark our key phrases within the AKS. I'm going to use a highlighter and you can do the same as well, or you can use your pencil. That's up to you. So I'm going to first mark my science and engineering practice of develop and use a model. I'm going to put squares around these, but you could highlight the words as well if you'd rather. I'm going to also mark the phrase natural selection. That's what we've been focused on throughout our unit, is the natural selection causing evolution to occur. I'm going to mark leads to changes. We've talked a lot about change over time. I'm going to mark specific traits. And then I'm going to lastly mark over successive generations as kind of a phrase together like that. If you need to pause the video, go for it. If not, keep going. So now we're going to go into each of our different highlighted phrases to kind of unpack what each of them means. So let's start with develop and use a model. So when we're developing and using models, and we've done that throughout the school year this year, when we're developing a model, we're going to create a visual representation. Scoot me down a little bit. Of a specific phenomena. In our case, we're looking at evolution through the process of natural selection. So I would say that is what developing a model would be, creating that visual representation, whatever that might look like. But then it also says we have to use the model. So I'm going to also add and to use that model to explain and predict outcomes. So it's kind of wordy. If you need to pause, go ahead and do so. My next key phrase on here is going to be natural selection. So I'm going to draw an arrow off to the side here to create kind of a specific space for this. And natural selection, we know, is going to be the process of organisms that are better fit for their environment surviving long enough to pass on their traits. So I'm going to reread that because it was a little disjointed. This says organisms that are better adapted to their environment tend to survive and produce more offspring. We know that that process of natural selection is going to lead to changes. We're going to see changes over many generations, not just an individual organism immediately changing when the climate changes or immediately changing when the environment around them shifts in color or in climate. We're going to see this over many generations. So we're going to think about what are the specific adaptations that would lead to those changes. So I'm going to draw a little arrow down here. And we talked about 3 different types of adaptations that might lead to these changes in these specific traits. So the first one was structural. And an example of that might be like a long neck of a giraffe. That would be a structural adaptation because it has to do with the shape of the body. So giraffes with longer necks are going to be able to reach food that maybe other giraffes with shorter necks would not. That gives them an opportunity to be more fit in their environment and to acquire resources that others cannot. So the second type of adaptation we talked about were behavioral. And an example of a behavioral adaptation might be a puffer fish puffing up into a little balloon for protection. And then lastly, you may have talked about this or you may not have, but we'll add it either way. The last one is going to be physiological adaptations. And an example of those physiological adaptations would be the release of poison, also for protection. Again, if you need to pause the video, go ahead and do so. If not, we're going to jump back up to our next phrase. So specific traits up here is going to be our next one. We know that specific traits that allow an organism to be more fit for their environment are going to be what allows them to survive and produce those offspring. And we know that organisms that produce variations or different versions of the same trait are going to give some of them an advantage and some of them a disadvantage. So next to where we have specific traits, I'm going to write genetic variation. Within a population allows some organisms to be better fit to their environment. We know that genetic variation in itself is only going to occur in organisms that reproduce sexually. We know that asexual reproduction is going to create organisms that are directly identical to the parent. So right above where I have genetic variation, I'm going to create a second little arrow off of it, and I'm going to write that this only occurs in organisms that reproduce sexually. So that leaves us with our very last phrase within our learning target here. And so I'm going to draw one more arrow below successive generations. And we know, and we've been talking about, these changes would be happening over many generations. So our successive generations are going to be the next generation of the species. And often these changes are going to take a really long time, sometimes even millions of years. So we're not going to see immediate change. We're going to see it over a long period of time, over many generations. So my last thing that I want to do is add an example to the bottom here. So I'm going to scroll down just a little bit. So this white space down here is where I'm going to use for my example. And so I'm going to just write the word example here. So for this example, I'm going to look at the genetic variation of color within a few different beetles. So let's say that the environment is green and leafy. And it has two different colors. Of beetles. Let's say one of the beetles is a green color and one of the beetles is a brown color. So let's draw some little beetles. These are not going to be realistic. They're going to have little smiley faces. We'll just give them a few little legs. So there's my brown beetle. And we'll draw a green beetle as well. All right. And so these are my two beetles here. I've got a brown one, I've got a green one, and I'm in a green leafy environment. So when I'm thinking about this particular example, I know that one of these is going to be better fit in a green leafy environment. And so I'm going to first identify which of these two beetles is better fit and least fit. So I'm going to draw a little arrow to the right of my green beetle, and I'm going to write that he's more fit to the environment. And then I'm going to draw an arrow to the left of my brown beetle, and I'm going to put that he's less fit. Because he's unable to camouflage, he's going to be more likely to be seen by a predator and be eaten by a predator. So, with that in mind, I know that this beetle is more fit and this beetle is less fit. My green beetle is going to have a higher probability of survival. And my brown beetle is going to have a lower probability of survival. So what does that mean? If I were to have the same number of beetles at the beginning of my study and I were to watch them over many generations, I'm going to begin to see that this heritable trait of green color is going to become more prominent. I'm going to see more of them and less of the brown beetles. As this trait is going to be more fit, it's going to allow them to survive long enough to pass their traits on. And so more and more of the beetles are going to begin to look like that more fit trait. That is everything I have for you as far as deconstructing or breaking down this AKS. So I'm going to try to zoom it out as far as I can so that you're able to see all of it within one frame. It's got a little bit cut off at the top. If you need to pause the video to get any of this down, please do so. If not, have a really great day. Bye-bye.